So, hello, my name is Vana Khurana. I work as an architect in a large financial company. So I started as a developer, tech lead, project manager, and now I'm working as an architect. And in my, not that I have a lot of free time, but I do teach at Temple University as an adjunct faculty. So I started as a developer long back, and when the internet revolution came, when the internet got commercialized, we didn't have an SLA for internet. If the application was running for 2 hours, that was good enough for everyone. If application didn't work right, that was still okay. Everybody accepted that. And what we did is that we would develop the code in my Linux environment or Unix environment back then, and then right away it will be elevated to production. And that was totally norm. And now we are talking about DevOps. The developers are developing and will go to production, automated. Doesn't look like we have come back all the way, but in a different way, much better way with SLA and with all the frills with it. So today I'm going to talk about the DevSecOps with DevOps with the security. So I'll take you to the journey from what I described, that back then when we developed and went to production, to the current DevSecOps, and how did we come and how do we really do it right. So once upon a time, so I'm taking you to the journey, there were waterfalls. We all know these processes, planning, design, requirement, all these. We are very familiar with those. Right? Our teams work together to push the things down, right? Because it is down. Once you gather the requirement, get the requirement signed off, there's no going back. If there is any change, if business wants to do any change, there is a scope change. So once they sign off, there is no iteration. They cannot really change their mind. So the team worked together, requirement team, the BSAs wrote the requirement and tried to push to the next phase. So analysis was done and pushed to the next phase. So there were issues with the waterfall. Business was not at the table, right? Business wrote the requirement, gave the requirement, BSA wrote it, and it's done. So throughout the SDLC, business was not at the table. No iteration, I just said that. Teams worked in silos. So requirement team never worked with the testing team or the design team or the developers, right? There was a lot of waste and rework. So according to the statistics out there, studies, only around 40% of the software which is developed are used, or the websites that are used. 64, actually it's more than less than 40. 64% of the websites are not, or the software is not really used or rarely used. So it's a lot of waste. Unnecessary features are built, because business didn't think of that, and then now it came when they saw half of the things and then they want to change. It doesn't work that way. Huge release time. We all know 12 to 18 months release time, right? When the project starts, project goes to production. No concept of MVP in the waterfall, right? Minimum viable product or minimum marketable feature, and the list goes on. So these are the silos: design, development, just to visualize. Then came the Agile and Scrum, right? Lot of talks about Agile, got a lot of good attention, and the Scrum team, they work together, right, with business. So business value is the focus in the Agile. Build the right thing, because business is always there at the table. Business is telling what to build, and they can change their mind, and they can say what they want next, and deliver the software accordingly, right? Iterating through the sprints, those 2 weeks, 3 weeks sprint, they build the right thing and iterate through that. Measure the velocity, how is the team doing, right? All good stuff with Agile and Scrum, right? That's the development and delivery team's focus. But then operations have goals too. What they want to do? They want to minimize the disruption. They want to eliminate the downtime. They want to increase the uptime. They really don't want any changes in the production, because their bonuses are determined how stable is the environment, not how many features are there, how stable is the environment. So they have conflicting interests. And this is the best I could draw. I'm glad I'm not my career doesn't depend on that, that drawing. And so Agile also has silos. So continuous development, it looks like this. I took this picture in St. Augustine. Going nowhere. You know, they develop, they churn through the sprints and keep shelving it. It doesn't go there anywhere, the continuous development, right? So what does DevOps add to? So this is a normal Agile cycle: code, commit, build, and do the integration test. That's the continuous integration, right? Then there is a continuous delivery: code, commit, build, int, test, system test, release, and deliver it. So the Agile projects, they have 2-3 week sprint. They, of course, all the good things, business is there, testers are there, they're testing, but then they keep shelving it. And it goes to delivery after it's kind of working feature or working product. But still it doesn't go to the production. They still wait for entire thing to build and put to the production. So DevOps adds the continuous deployment to it. It means that you added the release is with the continuous delivery, but you deploy to the production. And you do it in the continuous fashion. You don't wait for 6 months, month, or whatever. You do it in continuous. So what is DevOps? It's development and operations all in one team. It's a cohesive team following the Agile methodology. Nothing against that. The methodology is still good. And this is the second drawing. DevOps sitting on the table together. So what are some of the drivers for the DevOps? And we were, in the earlier session, we were trying to see, what are the drivers. So the one in the blue is the positive for DevOps, and one in the red is what we are trying to avoid from the DevOps, just the color code. But time to market. Business can't wait for 3 months to see a feature. They want to see as quick as possible, right? The risk of big releases. When there are big releases, you put in production, and these are those intertwined code, intertwined files, and if something goes wrong, you have to back out. It's too difficult to back out. You can't back out one piece from there, so it's too big to fail. Of course, back out of intertwined codes, almost the same thing. Knowledge transfer. So the development team develops and gives it to the support team, and they have no clue, right? They have no clue about the code, and they're struggling, and in that struggle and half learning, they do more damage. When there is enhancement and bug fixes, they introduce more bugs because they really don't know the code very well. So the DevOps cohesive team, that knowledge transfer is very easy. And of course, when you are doing the DevOps and when you are doing the continuous development, then you are making small features, small changes. And small changes are very easily controlled because if you are making 2-3 line changes, you can do a quick diff and see what changed, and the peer review, etc., will be so quick, as opposed to a 12 months or 6 months project. How do you manage that, right? So the DevOps adds this very easy to control feature as a side effect. Quick pace of technology. The technology is changing so quickly, and if you developers learn and they never transfer the knowledge to the ops, or if they don't sit together, they don't share, then the operations team or the support team are left out. And then infrastructure as a code. So everything these days are infrastructure. The virtualization has brought, or software-defined networks have brought the easy to combine the infrastructure with the application code. So you elevate the whole package together. And then, for example, firewall changes are in the code now. The security group with the cloud, with the virtualization, infrastructure has become part of application code. You elevate the whole thing together. So if an operation team is sitting in a silo, they have no clue what's going on. So back when DevOps or infrastructure as a code was not there, if you needed an environment, you submit the request, and the operations went and procured the hardware based on what you needed. They would install the OS, install the basic software, they will add the users, groups, etc. It took weeks, sometimes months, to get the correct environment. But infrastructure now, as a code, is you push a button and you have a virtualized cookie cutter environment, especially in the cloud, even otherwise. It takes minutes to get the ready. Infrastructure as a template, right? So if operations is sitting separately, they have no control. So what is in there for ops? And everybody here is a developer, or anybody does operations as well? Operations? Yeah, so what is there for ops here? You get to learn the new technology along with the developers. So when you have to really support it, you know what you're doing. When you have to do the enhancement or bug fixes, you know the code. Having a cohesive team of developers and operations together, then members can help each other. If there is a production call, they don't have to chase, where did that developer go? Who developed it? Because they are working together, right? And there is a product ownership. The DevOps team own that product together. So it's easy to get the funding. Because for development, the business is giving the fund, but if there are a feature or bug, then they will give the fund. But if there are bug fixes that they don't really see, the business doesn't see, they don't care about those bug fixes or the technology enhancement. So having a product ownership helps them. So we are talking about this, faster delivery. That's what DevOps brings. So Netflix, the popular movie, everybody knows, they deploy 100 times per day. They are getting this agility from DevOps environment, and they are adding the feature 100. This is a news item I just grabbed. Amazon, every second, they have a new software coming every second. So everybody is developing fast. So the question is, are we really delivering securely? Right? DevOps is very good, but everybody wants to be fast. Are we really delivering securely? So that's where it's DevSecOps. So DevOps with the security to make it really successful. So what is the goal here? I will talk about why. Why do we really do a DevSecOps? And when do we bring the security in? And who should be doing? And how? Some of the key enablers in there. So let's look at why. Breach is really costly. We know the story of Target, what happened. We know, they had billions of dollars in damages and fine. And it's detrimental to the morale of the employees. That's what happened to the Homeland Security Department. Employees' data, Sony, right? It can cost IT jobs. When the companies were hacked, the top executives lost job. Yahoo, Experian, Equifax, and the list goes on. Home Depot, Deloitte, Wendy's, right here in our neighborhood, Verizon, right? So, question is, what's stopping us from bringing the security in the DevOps to make it successful? So, business leaders think that the business value at the start of speed delivery, they think that the security is slowing them down. They are dragging them back. But if you look at the innovator's perception, then it provides them confidence to go as fast as they can. If you bring the security from the beginning in the DevOps, then you have that comfort that you can really develop fast and it won't go crazy. So what I'm saying that use the security as a differentiator, right? 91% of the organizations, when they Cloud Passage did a survey, and 91% of the organizations said they had security concerns, going to the cloud. So if in whatever business you are, if you are selling whatever product you are selling, your clients have those concerns, the security concerns, right? So security can be used as a differentiator. And if you look at the leaders, these two companies, Amazon, we all know that they are leader in AWS cloud, and Microsoft, Office 365. They're always bringing the security concerns first. They're always talking about how to make it secure, how secure they are, how security concerns they have, what security concerns they have. And they're using this as a differentiator. And then going to, when do we bring the security in? The DevOps, right? So I would say secure it by design. Bring the security in your pipeline. Make it part of your pipeline design. Allow time throughout the SDLC. And of course, we have regulations, many industries have regulations for timely security reviews, right? And I'll talk a little more what this timely means if the DevOps is continuous. When do you bring the security? But at least in the first go or MVPs, you can bring those reviews that regulation requires. And bake in as opposed to slap down. So you bake the security in to make your DevOps project successful from the beginning. Right? We don't want to really be the stories of those companies, right, with the DevOps. So who should do that though? Whose responsibility is to bring the security and make the DevOps successful? Security, we know, we heard this. Security is everyone's responsibility. But you need to train the developers. Because security in the DevOps model, security is not there. Right? If you were developing and giving it to the security people to test it, from the security point of view, do the vulnerability test, yes, they could have done. But in the DevOps, you're delivering every minute, every second, depends upon how efficient your environment is, or maybe every week or every day. Security is not doing a testing with you, right? So you need to take the development team has to take the ownership of the security as well. So you can train the developers to follow secure coding practices. By nature, none of the developers want to have an unsecured code. They don't get in the morning and say, today I will write an unsecured code, vulnerable code. They all want to do a good job. It's just that they don't have that mindset. They don't know how to do it, right? So the secure coding practices should be, they should be aware what not to do, right? Like, for example, input validation, etc. Those application OWASP top 10, etc. They should be aware. And encourage security champions. So every developer may not know everything. They're new, college hires, they may not know. Interns are there. So develop security champions within the team. That may be a volunteer, above and beyond job for some tech leads. And they know and they peer review that, and they make sure that those security stories are included in the Jira board or Kanban board, right? Create those security stories. Those champions will make sure. Or you can just have those set of security stories and then make sure that they go on each Kanban board, right? And who will conduct the assessment, those security assessments? As I talked before, that some regulations, some PCI, HIPAA, they all require that those controls should be there in a development process. Now, how do we do that now? Because the development is continuous, right? We can't do those anymore. We can't do the vulnerability test of each piece of code now, right? So what we do is that we make sure that its coding practices are learned by the developers. They are using the secure coding practices. Those security stories are completed, right? And then run the compliance report. So DevOps team can themselves run the compliance report and publish to the security team that, yeah, we are complying, we are doing this, right? And that's how, they look and that's satisfied. And of course, shift left. We all know shift left, finding the bugs earlier is much less costly than finding the bugs in the production. So this concept of shifting left for all the testing, do the same thing for security so that all the vulnerabilities are found earlier. But the question is, who will run those security or the functional testing, right? Who will run those? No one. No one will run those tests. The tests should be automated. So the developers will do the automation of the testing. You can't manually run. That's the one thing that slows down the DevOps pipeline. So no one, the developers, there will be automation of the test cases stories, and those then once they are written, then for each cycle you are running them over and over, right? So no, there shouldn't be any manual run of the test cases. We will rather create the automation and work on those test cases, automating the test cases than running. So it should be security or functional. So an automation is a big enabler for the DevOps, because we know that the pipeline is slowed down by manual work. If you have to test manually, then DevOps won't be successful. Machine will not miss anything. But we need to make sure that those automated test cases are good. So, and we can eliminate the human error there. So make sure that the test cases and the verification blueprints are created for automation. Templated secure design patterns. So if in the UI there is a form to have the names or the date of birth, the date of birth form should never have any other character other than the date. Numbers allowed, right? If you allow different characters, then that's vulnerable right there, because then JavaScript, etc. can be manipulated. So to make sure that those templated secure design patterns are pre-built so that developers can use them, right? And then ensure logging and monitoring and alerts. So even from the log from the pipeline, the errors from the warnings from the pipeline may be telling you something. So make sure that those are also logged and monitored, and security monitoring for the pipeline itself, and of course application. So automate the issue creation. So you have seen that DevOps pipeline spits out a lot of level 2, level 3 errors. Of course, the high errors are sometimes blocking. You can elevate further, but the lower level of errors sometimes go in. People don't pay attention to them. So I would suggest that we create the issues based on those errors, automated issue creation, and then run an analysis that which team is really ignoring those practices, and show them and run that analytics and show them that your team is really creating over and over this kind of error. So let them improve the process, right? And we talking about more enablers. Automation now. Can everything be automated? Can you just, as I thought, that firewall, security groups, etc. now is part of the code. Can they just open any port? Can they just use any protocols? No, you don't want to do that. So create a guardrail. Work with the security team to create a guardrail, and if the code is within the guardrail, then let it go. Let it go. But if it is not if outside the guardrail, then they block it, and then have a discussion and have a conversation. What should be open? In the cloud, everybody is moving to the cloud. Understand the shared responsibility model, right? AWS has advertised this shared responsibility model of the security of the cloud and security in the cloud, right? And our other cloud providers also say the same thing. If they say that their cloud is really secure, it doesn't mean that they secure your application also. They just secure the cloud infrastructure they give, right? So that is application developers' responsibility. And DevOps enabler, it's a big cultural shift. You have to have buy-in from the leader for the DevOps to be successful, especially DevSecOps to be successful. We shouldn't have, that, oh my God, DevOps. We shouldn't have leaders or security team look like that, right? It's really a change in culture. And learn from others' mistake. Target, after they were breached, they have really gone public with their DevOps journey. And I have the link here. They have multiple YouTube videos that how did they, come back, and how did they improve their process using the DevSecOps. So learn from people who have been there on the bad side. And then we don't have to really create a lot of things ourselves. There are a lot of toolbox tools are available, and this is just from RightScale cloud report that how the DevOps tools are used in the industry, and it's just a statistics based on the survey. A lot of DevOps tools are out there, and we just had a little conversation before this, that how do you enable, which tools you pick. So based on the platform where your application is running, based on the language your application is using, you can pick the tool set. There are a lot out there. And this also I created as, there is the kind of framework that you can, this is like prepare, plan, build, commit, test, and deploy. So you have on the top level, there are the tasks for DevOps, right? What all you do, create the project, especially the new product or new project. Who can create the new project? So the second row there is the controls and tools you can use to create to have some controls over them. And the last part is the deliverables, what gets delivered in that. So this is kind of a pipeline framework, and you can choose for your company what makes sense, so that everybody understands what needs to be done, who has access to which area. For example, in the prepare and the plan, you can have some automation, or the admin can create, the project admin can create those projects, etc., depending upon what's the culture of the company and what deliverables are there. And those, for example, automated test cases, right? And test-driven secure coding practices have to be utilized. Behavior-driven security coding practices can be utilized. So these are some of the deliverables or what you do. And then there are RASP and DAST, dynamic application testing. There are tools that can be used in the application for self-protection. So the DevOps pipeline has a lot of tools out there, a lot of security and testing tools are there. And of course, the monitoring of your SOC can monitor the environment and make sure that the logs are aggregated and analysis are run on those, so that you know that all those practices are utilized. Then I have this framework in a different set, that what really enables the DevOps, a successful DevOps shop. So microservices, those are everybody understands microservices, right? So they are the whole monolithic application can be divided into small microservices, and they are self-sustained, and they can be owned by one productized DevOps team. They are loosely coupled. One microservice is not really joined to the other microservice. It would be best if they own their own data. So if you have tables that are used by two microservices, then there is a kind of conflict. Who owns the data? Ideally, each microservice should have their own data, so divide there. Those teams will own them cradle to grave, the whole complete ownership, right? And those are some of the microservice enables the DevOps, successful DevOps, because of having the productized team. And if any feature is required, some changes are required in the microservice, then let other people submit the feature request or submit the requirement, and this team will own it fully. So, and then pipeline, make sure the previous chart had the pipeline. What can you do in the pipeline? So have some restriction who can manage the pipeline. Make sure the encryption is followed. Now some of the cloud environment, you can't even go unencrypted. They require HTTPS. Like for example, AWS, some of the services there, you can't even use non-encrypted. So make sure encryption is there. Source scan. Now peer review, in the old legacy development, you could, when the file was coded, you could send it to someone for peer review. They'll take their time to look at it. But with the DevOps, when you're developing and releasing, who's doing the peer review? Peer review still has some good value, because now if those two lines have changed, someone can check. But automatic code source scan, that's being utilized now. And there are tons of tools out there for making sure that the libraries you are using, if it's an open source library or commercial library, are there any known vulnerabilities? They quickly check from the CVE database and they warn you that, hey, this library has a known vulnerability, right? So source and or some of the design pattern, code patterns. So you can put those rules within the source scan software that if developer is using this pattern, just block it right there. Of course, keep in mind in segmentation, if your environment, if your company is using totally separating the development from production, so those design patterns should be washed. And productivity, there are serverless environment. How do you track those, right? So in the containers, if you are using containers, how you are scanning them? Make sure that the code is scanned, and support for forensic. In the DevOps environment, it's continuously developed and the code is changed. Who changed? When did they change? So make sure that those things are preserved. And security assessment. If it's not a 3 months project, of course security assessment cannot be done. So now you need to create your own reports and make sure that those are published and preserved, right? Otherwise security can come and say, hey, you didn't do the design review with security, but this is like every minute change. Defect tracking, make sure that development defects are also, those pipeline defects are also tracked, right? And development team has access to the data, how they are doing, those analytics, right? And the most important thing, that is DevOps is an organizational optimization. You have to have the buy-in from the leader, the cultural change. It's not a reorg. It's not hiring new teams, right? It's a reorg, not a hiring new team. You can find I've seen a lot of advertisement for DevOps engineers, but are they operation? Are they development? What are you looking for, right? So it's not really, and maybe they are finding the DevOps engineers, but for the teams, it's a reorg. You are just combining the operations with the development, right? So it's not hiring new DevOps engineers, it's combining them. It's a cultural shift and taking on the security responsibility. So that's the DevSecOps is kind of reorganization for most of the company, right? And food for thought. Would you consider reorganizing your environment, your business area also? Because we are talking about product ownership and microservices. So would you consider reorganizing your business area also to match the DevSecOps teams, microservices? Would you call it Biz DevSecOps? I think that's the next thing coming on, right? Biz DevSecOps. So that's all I had. Any questions? Yes.
Can you, let's see, well, is there any, so you mentioned a bunch of different things here about secure coding practices, running compliance reports, baked in, not slapped on. Do you have any either references you could recommend, like books or anything like that, or specific tools?
Yes. So the secure coding practices, there is an open web application security group, OWASP.
Oh, okay.
They have top 10 advertised, it's free. They have some code also you can adopt for free. And that is the golden set of secure coding practices.
Okay.
And you can create those modules based on the OWASP top 10. And in OWASP top 10, for last 10-15 years, the same vulnerabilities are in top 10. So people are really not changing their behavior. So, so we need to make sure that the new developers that come, they understand those risks. It's not that we learn and said the new top 10 came.
It looks like SQL injection is still number one.
Yeah, SQL injection is number one forever.
That should have been stamped out 20 years ago.
Right. So it's easy because it's the same set. So easy for us to create those patterns and teach the developers. And baked in, not slapped on. As I said, that you could create those based on your language or your development framework, or you can create those security stories and put in the Kanban board or Jira board, so that they are worked on by each team, so they don't forget it. And later, security comes and says, "Hey, you didn't do this," and blocks it. And of course, there's no later, because in the DevSecOps or DevOps, you're developing and you're putting into production. So those security stories are part of the project. And as far as the books, there are not really a lot of DevSecOps books, but there are a lot of YouTube videos from security point of view. And as far as the tools are concerned, there are a lot of tools out there. Like, if you just look for, maybe, I can't say this is better than that, but there are a lot, depending upon, your environment, what language you are using. So there are tools for static code scanning. So, and they work in IDE itself. So development environment, when coder is coding, it will warn you that this is not a good practice or this code is not allowed based on the rules you have set, right? So if a developer is putting password, hard coding a password, this right when they are writing the code, the tool will warn them that this is not good. And at the build time, you have those rules for passwords, hard coding, of course, and changing any security groups or firewall changes, those kind of infrastructure related changes, or opening all ports, to the word 0.0.0. You can create those rules. They're easily created rules that can be blocked before at the build time. So there are static code scanners. There are dynamic application scanning tests, and they kind of are designed for production environment. But not everybody is comfortable testing, in the production. So you can do it right before pre-production. I would encourage that, if nothing else. Those tools, when they sell you, they say you can put in production and it'll be tested. But you can do it right before production, so that you know what vulnerabilities are there. And then there are some tools that the newer tools that I talked about, DAST and RASP. They are.
I'm sorry. Please don't use acronyms.
Okay.
I don't even know what letters you're using.
Yes. So it's a DAST, Dynamic Application Security Testing.
Okay.
So those tools, they test different components and vulnerabilities found in the code. Mm-hmm.
What does RASP say?
RASP is it's a I can look up quickly. Don't remember.
Yeah, I'm sorry. This is like talking to our security guys. They rattle off a few things and says, "Have you set your firewall up?" It's like, no, I don't have a firewall because I don't expose my ports.
Yeah. I can look up what the acronym for RASP, but the application itself protects. So these are kind of a diversion from web application firewall, WAF, and but it's web application firewall is outside the application, right? But RASP is
Runtime application.
runtime
self-protection.
application, yes, runtime application security testing. So there are these tools that the agents run within the application. So when you are deploying them, they are compiled, they're linked these libraries are linked within the application, and when their application is running, they look for those known vulnerabilities, and the application blocks them itself. So application is kind of self-protection, while WAF is outside, web application firewall is at the perimeter, and RASP runs within the application. So you can apply both WAF at the web application firewall at the perimeter and RASP within the application. Mhm. So that way, it's more, you are taking the ownership of the application team is taking the ownership of the security. And it's very important to understand that, because now you are continuously developing, and there is no, planned security testing done by somebody else, right? Mhm. Did I answer all the questions?
Yeah.
Okay. Any other question? Anyone is doing DevOps over here? Yeah, you're doing?
Starting.
Starting? Yes, starting. Yeah. Yeah, if you make sure that, all those, it's difficult, to put everything together, but at least when you are aware where you want to reach, then you can design your pipeline and your culture environment from the beginning. We don't want to be one of those bad stories.
Sure, there's a lot more bad stories that occur though. If people still have SQL injection errors today, we know we're going to have trouble tomorrow.
Yeah. Yes.
It was the biggest problem 25 years ago.
It was, and it's still there.
Still is.
It's still there. All right, thank you for coming.
Thank you.
Thank you.